A very good day to our lecture. Okay, today I'd like to present about the project report on topic of electric kettle. So these are my group mates, which is Satishwaran, Satyarao, it's me, and also Yuvaniswari. Okay, now we like to talk about the electric kettle. Okay, an electric kettle is a water heating appliance with a self-contained heating unit that turns off when the water reaches boiling point or minimum temperature below 100 degrees Celsius. Okay, I got some advantages, which is insensitive to hydrodynamics. High heat fluxes are possible, can handle high vaporization, simple piping, and also unlimited area. Okay, next, okay, we talk about the block diagram of the kettle. Okay, starting from the input switching on, goes to relay and heating element, and also next to electric kettle plant, and last is a hot water output. And below is the thermostated feedback elements. Okay, for the control system inputs, the switch on button that turns on the electric kettle, while the output is hot water generated at the end according to the block diagram. Okay, relay heating element, electric kettle, and also thermostat make up the subsystem. And the optocoupler relay collects data from the electric kettle, switches sensor, and sends it to the heating element, which heats the water. The heating element is the actuator, and it depends on the temperature of the water. If the water is cold, it will take longer and use more current to heat up. Electric current travels to its heating element, gradually heating it. And when the temperature exceeds the set point, the system feedback mechanism, including the thermostat, kicked in, and the thermostat detects the temperature of the kettle and transmits that information to the relay. The kettle's electrical power source was then switched off by the relay. Okay, these are about the block diagram of the kettle. Then next about the technical specification. Okay, these are technical specification of the kettle. Capacity comes to 1.5 liter, rated frequency 80 Hz, input power 1800 watt, voltage 220 volt, at temperature comes to 100 degrees Celsius, power factor 0.45, and etc. Okay, these are the dimension, the weight of the product. So product dimension comes to 216 centimeter, which multiple by L times W times H, and packaging dimension also same. And finally the product weight comes to 0.8 kg. Okay, for the kettle shows, okay, right side goes to TS, left side to ES, and also up goes to right side is axis. So this is electrical equation. Okay, next for the transfer function, GS equals to output over input, so TS over EA. So the open loop transfer function of water in MATLAB by defining the parameter and transfer function as below, as follow. Okay, these are the things that we need to follow, and we will put in the MATLAB to get the result. Okay, by running the code in the common window MATLAB, coding use the MATLAB common window. Okay, these are things we are used in the MATLAB. Okay, the first step response for the open loop system, and second one is the pole zero map for the open loop system. So next, okay, for next we using the second coding used in the MATLAB, and here shows the step response of the second order open loop system. So same as just now, and for the combining step response for the first order and second order system shows this.
A very good day Abid to our lecturer and also my fellow colleagues. On this day, I'm going to present about the task 2. We'll be starting about task 2. Okay, for the task 2, we'll be first relating about the discussion. For discussion, we'll be determining the set line timing and the final speed output from the graph. The graph means where the graph we've been obtaining from task 1 with the settling time is 0.098 seconds to be. Moving on to the next part. For the settling time, the step response graph is 0.098 seconds. We obtain is 0.0476 as the final speed result from the graph. Okay, for the second one, the steady state error may be estimated by looking to the graph and assuming that the input causes the error where the total speed divided by the time taken and times by the 100% for the efficiency will be 4.86%. This shows that our overshoot at the peak in our transfer function because the system is provenly overdamped. Okay, for the task number 3, moving on to the task number 3 will be the task of lag compensator. Okay, a lag compensator is one of the type controller known to be able to reduce the steady state error. Okay, for the we can use the control system designer to design our lag compensator. It's an electrical network which which produce a synodulous output having a phase lag when the synodulous output is applied, where the capacitor is in the series, where the circuit is being arranged in a series form, and where the resistor and the output measured in a series method. Moving on to the next most important point in task 3 will be root locus. The root locus is a graphical representation of S domain, and it's asymmetrically about the real axis. What do you mean by S domain? Is the main domain where the symmetrical lines occurs in the real axis. Okay, because the open loop poles and the zero exist in the S domains having a value either as a real or a complex conjunction pairing. Besides the determination of the stability of a system, the root locus can be used to design a damping ratios and also the natural frequency for the system to run in a manner. Moving on to the natural frequency line can be radically from the source, and the constantly damping line are cosigned with the central point and coincident with the origin which has been drawn in the graph. There are 7 rules for our root locus construction. For the rule number 1, we'll be locating the open loop poles and the zero in the S plane. For the rule number 2, we'll be finding the root locus branches. For the rule number 3, we'll be identifying and drawing the real root locus branches with a real symmetrical line. For the rule number 4, we'll be finding the centroid and the angle of a esmortitus. For the rule number 5, we'll be finding the intersection point of the root locus branches with the imaginary axis from the real line or this real symmetrical line when we draw in the task number 2. And the rule number 6 will be finding the breakaway and also the break-in point. And for the final rule will be rule number 7 with the angle of departure and also angle of the arrival of the root locus function. And besides root locus, the blow plot is also the main standard format in which the LTI system can plot their frequency response in the format of the standard format using the format facilities communication between engineers. And besides, the common system behaves produce simple phases such as the straight line, and also the breadboard is easily either look at the plot and also recognize the system behavior. That's all from me. Thank you.
Hi everyone, my name is Yuneshwari. Let me start with task 5, PID controller. Proportional integral derivative. PID controller is the most common control algorithm used in the industry and has been accepted universally for industrial control. PID controller can partly be attributed to their performance in a wide range of operating conditions and partly to its functional simplicity, which enables engineers to operate them smoothly. The PID algorithm, the name indicates, consists of 3 fundamental coefficients, that is, proportional, integral, and derivative. Next, proportional response. The proportional component depends only on the difference between the set point and the problem variable. The advantage of proportional response is minimize deadline from stiction and backlash, minimize rise time, minimize peak error, minimize integrated error. The disadvantage is attribute changes in output upset operators and changes in output upset other loops. Integral response. The integral component sums of the mistake over time. The advantage is eliminate offset, minimize integrated error, smooth movement of output. The disadvantage: limited cycle, overshoot, runaway of open loop unstable reactors. Next, derivative response. The derivative components cause the output to decrease if the process variable is increasing rapidly. The advantages are minimize deadline from stiction and backlash, minimize rise time, peak error, and also integrated error. Disadvantage: abrupt changes in output upset operator and other loops. Amplification of noise: the process variable is increasing rapidly. That's all from us. Thank you.